This is C3 January 11, question 7. We have a function for f of x is log of x, a function for g, which is x squared plus 8. And part 1, we've got to find the exact positive value for x, which satisfies the equation fg of x equals 8. Fg of x means we put g of x, which is x squared plus 8, into f. And f says whatever the input is, we log it. So log of x squared plus 8, that is the function fg, and we're told that equals 8. So we've got to solve this equation. So we need to get rid of the logs, which means we do an anti-log or inverse log or e to the power, whatever you want to call it, to both sides. So x squared will be e to the 8 minus 8, so x will be the positive square root of that. E to the power of 8 minus 8 square rooted. So that's the first part of that question. Part B, the second bit, says which function has an inverse and what is that inverse. So we have two functions. We have a squared function and a log function. The squared function, xy equals x squared plus 8, will look like that. And for any y value you choose, there are two x values. So it doesn't have an inverse, not unless at least you restrict the domain of that function. So log of x is the function which does have an inverse, and the inverse of log is e to the x. So y equals e to the x is the function. And we need to state as well where the function is defined, and you can put any value you like into there. So x could be any real number. So the answer to the second part of the question is y equals e to the x, where x can be any real number. Part C says find the exact value of the gradient of the curve y equals g f of x at the point where the x coordinate equals e cubed. Well, we haven't come across the function gf before. We had it the other way around. So g of f of x means log x, which is f of x, is put into g, and g says whatever you get, you square it and add 8. So y is going to be log of x all squared plus 8. And we need to find the gradient of the curve, so we need to differentiate this. Differentiating log squared, a couple of ways of doing it. One is to write it as log x, and then use the product rule on that bit. So that's a u, that's a v. When we differentiate the 8, we'll get 0. So using the product rule on this, it is v du dx plus u dv dx. So in other words, it's two lots of log x over x. So that is the expression for dy dx, and we've now got to see what happens when x equals log of 3. Sorry, x equals e to the power of 3. So we've got 2 log e to the power of 3 over e to the power of 3. Log and e are inverse functions. They effectively cancel each other out. So log of e to the 3 is just 3. So I get 2 lots of 3 over e to the 3. So it's 6 over e to the 3, or 6e to the minus 3. Whichever way you want to write it, they're equivalent. The final part of this question is asking us to use Simpson's rule. Simpson's rule can be found in the formula book. Just find it quickly. Simpson's rule is on page 5, and it comes down to be basically 1/3 h, where h is the width of the intervals, and then you times it by the y of the end values plus 4 lots of y of the odd values plus 2 lots of y of the even values. It's not the way it's written in the book, but that's the way most people interpret it and use it. So if we just draw a graph at the moment, we've got a function, we don't really know what it looks like. Just put any old curve down for now, doesn't really matter. But we're going between -4 and 4 in 4 strips. Well, if I put it down there, no, that's 2 strips. So doing it again, that's going to be at -2 and at 2. So I can see for 4 strips, 1 strip, 2 strips, 3 strips, 4 strips, my x values are going to be -4, -2, 0, 2 and 4. So I'm going to have a little table here. I'm going to have an x0 value, and x1 and x2 and x3 and x4. That's going to be -4, -2, 0, 2 and 4. Now for each of these I need a y value to go with them, so those are my x values. The formula I'm dealing with here, or the equation rather I'm dealing with here for f of g, let me just get this right because in part 4 I'm doing f of g, and f of g we've already said is log of x squared plus 8. So that's my y equals bit, if you like, that's my function. So when x is -4, square that, I get 16. 16 plus 8 is 24, so that's going to be log of 24. Here, -2 squared is 4, plus 8 is 12. When x is 0, I'm going to get log 8, and here I'm going to get log 12, and here I'm going to get log 24. So that's an end, and that's an end. This is an odd one. This is an odd one because of the 1 and the 3, and this one here is an even one. So the formula I had up here for this rule is I need the ends plus 4 times by the odds, so that's got to be times by 4, that one's times by 4, 2 times by the evens, and then a third of h. And h is this gap here. These horizontal gaps are all 2. So at the top, this is what I'm now going to be working out. It's 1/3 of h, the ends, so that's log of 24 and log of 24. Then it's 4 times by the odd ones, which are log 12 and log 12. And twice the even ones, which is log 8. So that's the expression I get. So I've got here 2/3, and in here I've got 2 lots of log 24. I've got here log 12 plus log 12, so that's 2 log 12 times by 4, so that's 8 log 12, and over here plus 2 log 8. And it's a case now of putting that into a calculator and getting an answer out. Put that into a calculator, you get 20.26, which is the approximate value of the integral that you had to find. And that's that question completed.